Hi, everybody. So this is part 2 of lesson 3.2.4. We're going to look at unlike denominators. You should have already understood the problems for like denominators and tried the ones on the assignment 1 through 4. That way you're familiar with them. All right, so these problems are much harder because, again, it's unlike denominators, which just adds another thing we have to figure out for these problems. So the key is, just like in elementary school fractions, you have to have a common denominator. So let's look at this example. You guys know that the common denominator off the top of your head, you guys would immediately pick 15, but maybe you don't realize the reason you're picking 15 is because you're looking for the lowest common number that they both go into. Well, it's actually you're taking 3 and you're multiplying it by 5 because each of those is at its lowest factorization. Like 3 times 1 is the only thing that makes 3, and 5 times 1 is the only thing that makes 5. These are at their lowest factorization, so the common denominator is 15. Then what's the next process? Well, you don't get to just change the denominator to 15. The reason we changed it is because we're actually multiplying top and bottom by a 5. 5 times 3 made it 15. 5 times 1 makes this numerator 5. And over here, we multiply top and bottom by 3 because 3 times 5 is 15 and 3 times 3 is 9. And now that the denominators match, we're back to easy problems. 15 plus 15 on the bottom, you keep the 15 on the bottom. 5 plus 9 is 14, and that's it. If I could simplify from here, I would. All right, now let's look at one more example before we do actual rational expressions problems. So again, here we have unlike denominators. And so maybe off the top of your head, you immediately say, oh, 12 is the lowest common denominator. But do you actually understand why you're getting that? The reason is 4 can be broken down to 2 and 2, and 12 can be broken down into a 2 and a 6. But you know what? I'm going to break the 6 down further into a 2 and a 3. This is what I call the factorization of a number. It's basically all the lowest numbers that multiply to make that. All right, so now what is the lowest common denominator between these? What we're actually doing in our brain without realizing it is we're taking this 2, and there's 1 in each, so these green 2s, and then we're also taking these purple 2s, and then the only thing that's not circled yet is this 3. So we're going to also take this blue 3. It has to be in one or both. So that's how we end up with the common denominator of 12. You guys are so used to doing it that you don't even realize how you got a common denominator of 12 because the process is just easy to you. You can see it. Well, in rational expressions, you won't be able to see it as clearly because there's variables. So the common denominator is 12. Now again, let's look back here. This denominator had a green 2 and a purple 2. It never had a 3, so we multiply top and bottom by 3. 3 times 4 is 12. 3 times 11 is 33. This denominator had all of the features. It had a 2, a 3, and a 2. So we don't need to multiply it by anything. We add the tops. 33 plus 5 is 38 over 12. And now can I simplify that? Yeah, so 38 divided by 2. We can take a 2 out of the top and a 2 out of the bottom, so 19 over 6. All right, so do they teach it this way in elementary school? Probably not, because students would have a hard time seeing all the factorizations. They usually just say, think of a number that they both go into. Well, in rational expressions like we're going to look at in the next problem, it's really important to understand how we can get a common denominator, because it's not going to be something you can just look at and know. So go ahead and write this next problem down, pause the video if you need to, and then we are going to do our first problem. Okay, so number 4. Do we have a common denominator? No. Do we need one? Yes, because we have a minus sign or a plus sign. If it's multiplication or division, you don't need a common denominator, and you can cross cancel. In subtraction and addition, you need a common denominator and you cannot cross cancel. So, what are we going to do? All right, we're going to find our common denominator. So let's see. I'm going to do the problems like this. I'm always going to rewrite them with the common denominator. So it helps me personally to look at this as a 5, a V, and a V. And over here, I look at this as just a 5 and a v. I'm not going to rewrite it because it already has a 5 and a v, nothing else. So I kind of broke it down. Now I'm going to ask myself, what do I need to have? So I need to have this 5. So this 5 in both. And then I need to have this red v. So I circled it once in both. You're not allowed to circle it more than once. Well, there's an extra v that needs to be in both, this blue. So I wrote that. What is the simplified version of this? 5v squared. So you know what? I'm just going to write that, 5v squared. That's how I would have written it in the first place, but I wanted to be sure that you understood where I got those v squareds from. Okay, so now what do we do? The same thing you did before. Think about what's missing. So I'm going to erase this and look at what's missing. I'm not paying attention to this line. I'm not paying attention to this line. I'm just paying attention right here. So you know what? The first one looks exactly the same. It already had 5 with v squared, so I don't need to change anything about the first one. It already had the common denominator. But that's not true about the second one. The second one had only a 5v, but it needs to be a 5v squared. So you know what I'm going to do is multiply top and bottom by v. 5v times v is 5v squared, but if I do it on the bottom, I need to do it on the top, giving me 2uv. All right, that was the hardest part about these problems, because now you're going to back to the other part where you just subtract, and you just carefully subtract. 5u minus, this is not a like term, so I can't even do anything with this. That's it. And then the denominator just stays 5v squared. Now you want to ask yourself, can you pull anything out? You can't cancel right now because it's connected by a plus or a minus. Could you pull anything out of this? You could pull out a u. Will it help you? No, because there's nothing to cancel with. So I just want to show you, could you pull out a u here? What would that give you? 5 minus 2v. Yes, but you wouldn't be able to cancel. So what's your final answer? This answer in pink is absolutely fine, or somebody who tried to pull out the u and 5 minus 2v and then realized, oh, nothing cancels, and they left it. This is also an appropriate answer. Either one of these are fine. We are not focusing on finding excluded values for these problems. Do they exist? Yes, but we're not worried about them for this section. You won't see it on a test where you have to state excluded values for adding and subtracting. Okay, if that was too fast, you rewatch it and try that problem again. I'm going to move on to the next one. Go ahead and write the problem down, pause the video. All right, so this problem, I'm going to connect the pluses to remind myself they're connected. They're a factor. So you know what? I need both of these on the bottom. One thing I would personally do first is pull out this 6 in front, because it might help if we could cancel it, and you'll see that we can. So I'm going to pull out the 6 in the front. So my first, I'm just going to rewrite it over here. It's going to be 2k over 6 over k plus 1. Now, what does that help? Well, you are allowed to cancel, because otherwise I have to put a 6 as part of my common denominator. But you know what? I'm just going to cancel this 2 and this 6. 2 goes into 6, 3. So I am going to rewrite the entire first fraction as 1k, or just a k. So all that's left on top is a k, and on the bottom is a 3, parentheses k plus 1, minus 5 over k plus 2. Okay, so now, do these denominators match? Nope. How many things do I need in the denominator? I'm going to need a 3, I'm going to need a k plus 1, and I'm going to need a k plus 2, because nothing matches at all. None of the factors matched. At least in the last example we did, some stuff matched, or a lot of stuff did, right? In the last example, some stuff matched. But in this example, nothing matches, so my common denominator is going to be a 3, a k plus 1, and a k plus 2. a 3, a k plus 1, and a k plus 2. Okay, well now what do we do? Well, now what we can do is we will check what's missing. So look at the first fraction. What's missing on the first fraction is a k plus 2 on top and bottom. If I do it on the top, I have to do it on the bottom. So I'm going to multiply this by a k plus 2 over a k plus 2. We're allowed to do that in math. We're just multiplying by a 1. This is just a 1. I am going to distribute as I rewrite this. K times k is k squared. K times 2 is 2k. I have made my new first fraction. All right, let's keep going. On the other fraction, let's see. I am missing a k plus 2, a k plus 1 and a 3. So I'm missing a 3 and a k plus 1. A 3 and a k plus 1. Will that make the denominator look like this? Yes, 3, k plus 1, k plus 2. So now let's carefully deal with this top. 5 times 3 is 15. That 15 needs to get distributed in here. So these two make 15, and then I'm going to distribute them in. 15 times k is 15k. 15 times 1 is 15. Okay, we are almost done. That was definitely the hardest part. And yeah, if you didn't understand it, you may want to rewatch this. All right, so now what do? The denominator stays exactly the same. 3, k plus 1, k plus 2. Just be careful when you subtract. Don't forget you subtract both of these parts. I can't tell you how many students do everything correct and forget to subtract both parts at the end and get it wrong. So we have a k squared. We have a 2k minus a 15k, which is negative 13k. And we have a minus 15. And this is my final answer. Now you may want to ask yourself, can we factor this? You're right. We should try, because what if it suddenly cancels with a plus 1 or plus the whole parentheses? But if we take a quick look at the x, negative 15 on top, negative 13 on the bottom, there's no way that'll work. 15 times 1 won't work, or 3 times 5 won't work. So it's not factorable, which is good news. This is my answer. If it was factorable, you'd try to factor, because you never know when you can cancel. All right, we're going to do one last example. And again, if this went too fast, you can rewatch it. So example 6, go ahead and write it down, pause and write it down. All right, so I am going to factor the top and the bottom here to see what happens. So if I take out a 2 from the top, I'll get a 3x plus 1. And if I take out a 3 from the bottom, I'll get a 3x plus 5. Wouldn't it have been nice if something canceled? Yeah, but nothing's canceling. And that's okay. That's fine. So maybe that was pointless. But you know what? It helps me see I already have a 3 and a 3. So think about, what is your least common denominator going to be? One of those 3's, because it's already in both. And then I also have to put in a 3x plus 5. So my common denominator is 3 times 3x plus 5. The good news is this one already looks like that. This fraction already looks like that. So I don't need to do anything. And I'm going to go ahead and multiply the top back, or you can look at it right here, 6x plus 2. All right, now what about this first fraction? The first fraction is missing the 3x plus 5. So I need to multiply that by a 3x plus 5 on top and bottom. Well, 3 times 3x plus 5 is already written. I'm going to multiply this 5 into both of these. 15x plus 25. Okay, that was the hardest part about this problem, and hopefully we don't make any mistakes along the way. And now we just keep the denominator exactly the same, 3x plus 5. and we add the tops. 15x plus 6x is 21x. And 25 plus 2 is 27. And then you look on the multiple choice test and you're disappointed because you didn't find your answer. Hopefully it's not that you made a huge mistake. Hopefully it's just that you didn't realize there's something comes out of this. A 3 comes out of the top, which leaves me with 9x. I'm sorry, not 9x, 7x. So a 3 comes out, which leaves me with 7x plus 9. Okay, and then you see that 3 on top and the 3 on the bottom. Can you cancel them now? Absolutely. So all that will be left is a 7x plus 9 on top and a 3x plus 5. Can we cancel these 5s? Nope, because they're connected to a minus or a plus. All right, so do I think this is an easy lesson? No, I think it definitely, probably you're at kind of like a 2 or a 3 after this notes, and then hopefully by the end of the examples that you do yourself, you're maybe at a 4. But it's okay if you're not. We will continue learning a little bit more about this on Monday. This is the last new section we need to cover. All right, so go ahead and work on numbers 5 through 7 on the assignment, and you can always ask me for help on Basu Live.